Hello everyone, I'm Karthik and welcome to my channel. Today we are going to create a simple vellum hair simulation, something like this. So let's get started. So we'll start with a geometry network. Let's name it Sim. You can color it if you want. And we'll go inside and create a circle node. I want this to face in the X direction. So this is it. Now let's increase the division. Let's make it 50. I'll open the arc, and now this is an open curve. What I want is I want it in a C shape, so I can decrease the angle from here, but I want to decrease the angle from both the sides. So just revert to defaults, copy this parameter, this angle, and minus base relative reference. Now when we decrease the angle, we'll decrease both the arc angles equally. Something like 35 is okay. Now let's resample it. Decrease the maximum segmental to 0.05, and we will turn on curve view attribute. This is important. We'll use this curve view attribute later to color our geometry. So after this, we will use a sweep node and change the surface type to round. We'll get a tube-like shape. Let's increase the radius here, around 2.8. The ends are open here, we want close ends here, so I'll just come to the end caps and use grid here. So this is looking nice. We'll also apply a scale along curve and change the shape like this. I'll select all the points and set the interpolation to more than a cubic. You can make your own changes here, the shape doesn't matter much. After the sweep node, we are going to use a normal node to create normal vectors. Set the normal, add normals to points, and now we have normals on our geometry. Now we are going to scatter points here. Let's increase the number to 3000, and all these points also inherit the normal attribute now. As you can see, you can turn on the normal from here, you can visualize the normal from here, and you can see that all the points have inherited normal. After this, we will create our line. So let's create the line over here. Use the line node. We want it in the Z direction, and we'll increase the points to 10. You can see there are 10 points here, from 0 to 9, 10 points. You can also check here, there are points 10. So what we want now is we'll use a resample node again, and we will turn off the maximum segmental. We do not want to increase or decrease the points here, but we do want curve view attribute. We'll use this to color our hair later in the simulation, later in our project. After the resample node, we are going to use a group expression node, and let's change the group name to PNTS points, or you can name it anything. We are going to use a template here, which is first point of perimeter, and keep in mind that for this to work, the group type needs to be points. So what this expression is doing, that is, this is our primitive line, this is our primitive, And with the help of this group expression, what we are doing is we are choosing the first point of this primitive, the 0th point, and putting it in a group called points. As you can see, point groups, and this group has one point which is over point number 0, which is the first point of this primitive. So that is what this template does. We are going to use this point, the point number 0, in our simulation as a static point. So everything else in this line will work in the simulation. Everything else will react to the simulation, to the forces, except the 0th point, and that is because we will keep it static. So let's move ahead. Use a copy to point nodes now. Now we have copied our line to all the points that we have scattered earlier. These are the points that we scattered, and we have copied this line with this group to these points. So we have around 3000 hair or lines here, and all those lines first point is in the group. So if you check here, you'll find that the point group has 3000 points. So now we will create our Vellum constraints and Vellum solver. So let's create our Vellum hair constraint now. Use a Vellum hair configure node. You can use the Vellum, this one, Vellum hair configure hair node, and after this we'll use the Vellum solver. So this is it, but this is not the shape of the hair that I want. What I want is all the hair needs to have different P scale, different length here. So what we can do is that let's come to the copy to points, and after this scatter here, what we are going to do is we'll use a attribute adjust float node here. This is already set on scale, is set always. This is already set on P scale. Come to the adjustment value, operation set always, and pattern type is noise. So we will have a minimum value, maximum value. So let's just see what happens now. So this is what we are getting after applying a variable P scale value for all these different points. Let's make changes in the minimum value. We'll make the minimum value to 0.05, and maximum value is 1 is too much. So what we are going to do is let's decrease it to 0.5. This is better now, but we can improve it now. Use the remap ramp here and make it a little contrasty, and let's increase the element size till you are satisfied with the length of the hair. So this is looking nice, and now we can move ahead with our simulation. Come to the Vellum solver and let's see what happens now. So as you can see, as expected, the hair are all falling down because we have not done two things. First, we'll have to let's come to the Vellum hair constraint, and in the pin to animation section, come to pin points and select our group points. So now you can see that all those points, all the first points of all these hair is being put in the pin points section, and they are basically uh, keeping they're basically being static now in the simulation. They are not going to react to the simulation or forces of any kind. So let's run the simulation now, and we can see that everything, all the points except the points in the group points, all the points except the one that we just made the static points, are reacting to the simulation, are reacting to the gravity in the simulation. You can turn off the gravity from Vellum solver, come to the Vellum solver, gravity, and turn it 0. And now when we run the simulation, we can see that nothing happens because there's no force. Let's dive inside the Vellum solver and we will create our own forces. Force, we'll use a pop force, and let's increase the amplitude to around 7. Yes, 775, and let's see what happens now. Okay, so this is moving, but what I want is I want these hairs to bend a little more. So we'll come to the Vellum hair configuration and come to the bend section, and we will decrease the stiffness of the bend of this hairs. So what I'm going to do is I'll come and decrease it to 0.001, and now they are flowing better. But they are moving a little fast, and I want them to flow like they are inside water. So let's come to the Vellum solver, and we will use a pop drag. Here what this pop drag does is it decreases the force, or it basically increases the air resistance. You can see air resistance in 1, and it decreases the movement of the simulation because there is resistance of air in the simulation now. So let's run it, and now you can see that they are flowing better. They are flowing like it is seaweed or it is underwater, and that's the look that I was going after. So after the simulation, what we are going to do is now we'll generate the polygon, we will generate the geometry for all these here. So after the Vellum solver, we'll use a sweep node, and just like before, we are going to use a surface shape and make it round. But here what you will see is that it is not working properly. You can't see the hair clearly, and this is happening because the Vellum solver creates a lot of attributes that we do not need now. All these attributes are somehow affecting our sweep node, and that's not what I want, sorry. And I'm going to use the attribute delete node here, and will delete all the attributes coming from our solver. So now let's see if this sweep node works, and this is behaving differently now. So let's decrease the radius here. Decrease the radius to 0.02. Okay, we'll come to the end caps, and this time we are going to use single polygon, and it is looking okay. Let's apply the scale here. And you can shape it however you want. You don't have to copy my ramp here, but this is what I'm going after. I'll just select all the points and I'll set them to B-spline, or actually monotone cubic. And yeah, this is looking nice. So let's run our simulation now. Increase the, we can increase the radius from here 0.025, and this is basically looking like seaweed now somehow. As I said, you can change your shape if you want. So yeah, this is looking okay. Sorry, this is looking okay now, and we'll move ahead. And what we need now is we want to color our geometry, and for that we'll use the curve view attribute that we created earlier with the resample node. So let's come to the line, and after the resample we'll use a color node, and what we are going to do is we'll use ramp from attribute and use the curve view attribute here to color our line. So you can basically see that we have colored our line with the help of a ramp attribute, and that attribute is curve view. So what is happening here is the curve view attribute actually creates a value from the first point to the last point of a geometry, and that value is from 0 to 1. So if I just turn on the curve view attribute here, and this color, what I want is a marker. See, this is the curve view attribute, and that curve view attribute is being applied to all the points in this line. The first point of this line has a curve view attribute of 0, and the last point has a curve view attribute of 1. And with the help of this ramp, this attribute, we are applying our color. The first point, the 0th value of curve view attribute, has black color, and the last point, that has a value of curve view attribute 1, has white color. And this is how we can color our curve here, our line here. So I'll turn on the grid here, and let's color this differently. I want pink here, not that pink, it's too dark for me, too contrasty. And the last color I want is yellow. In the middle, I think I want a white color, and I'll increase the, yeah, this looks nice now. Now that we have colored our line, when we copy this line to our points, all our generated hair will have this color. And when we finally sim this, this is how it is going to look. And we can sweep it also, but we are not going to get our color in the sweep because after the Vellum simulation we have deleted all our attributes. So we have to come to the attribute delete node and delete everything except CD. So this up arrow and CD basically is telling the node that delete everything except the CD. This up arrow is important. If you want to delete and not delete anything, then you will have to use this up arrow. So now we have our color in our geometry as well. This is good, and we can move on to lighting and rendering, but you can see that there's no base for these colors now. We do not have any geometry in the middle, and we want that. And I also want to turn all these to baseline. I don't want it. Yeah, okay, this is looking now nice. We want geometry, and we can take our geometry from the normal, take it to the bottom and merge it with our simulated geometry. But you will see the problem here that our base geometry does not have any color, and we do not want that. So what we are going to do is, we have a curve view attribute here as well. In the resample, we created a resample here. So what we are going to do is, we'll use the same color node after the resample. And when we sweep it, our base geometry will have the same color. But before we can merge them later, I will show you one more thing that you will have to do, and that is, you will have to attribute delete our color here, and I will tell you why. Let's just turn it off for now. Now see, what is happening here is, when we did not color our geometry, we were getting a different color here. See, all the hair here had in the beginning pink color, in the middle white color, and at the end the yellow color. But when we color our base geometry, the colors change, and that is happening because, just like when we created our normal node and all the points inherited the normals here, just like that, when we created our color, all the points also inherited the color, and those color are being inherited by these lines as well when we are copying them. And we do not want that. We want all the lines to have their own color, just like we created here. And so basically what is happening is, there are two colors here and two curve view attributes, and so we are going to use our attribute delete node here as well. Before the copy to points node, we'll delete this color, and we will also delete the curve view. And now when we copy all the points, all the lines will have their own color that we generated here. They will not inherit any color from our base geometry. As you can see, if I turn off the attribute delete, the lines will inherit the color from the geometry, and when I turn it off, I delete the CD and curve view, line will have their own color, and that's what I wanted. So after everything else, after we have done everything, this is the final result that we'll be getting, and we can sim it now. Let's sweep the hair and give it a base geometry. So this is our final thing, and after the merge, the only thing that remains is, we'll use a transform node, and before we render and light this stuff, what I'm going to do is, I'll decrease the uniform scale of this, because that's how I like to work. I like to work with small geometry, small scale geometry, so it is easier for me to light and shade it. Easy it is for me to light when I follow real life scale. So I'll just null it. So now what we are going to do is, now we will be creating lights. So we'll use a RS light, and I'll name it front top, because this is the line that will be on top and in front. So just copy this, sorry, just move this, move in at top and rotate it a bit. So we are lighting our geometry from this angle, and this is a little big, so we'll decrease the size of our light, and I'll just turn it, I'll half it. 0.5 looks good to me, and I'll also decrease the intensity. I'll make it 1 for now, and let's decrease the spread as well. I'll also copy this light and I'll use this one as a backlight. I'll decrease the spread here, and you know what, I'll just increase the intensity also on both of them. 0.5. We can change our settings for the light once we render, but when I'm working with small scale geometries, it is easier to start with low intensity lights. So basically this is what I did. It was on the bulb, which is normal lighting, and I just switched it to headlight only, and for the viewport, so that I can see it properly. You can find a angle which you like and just control and hit the camera, and this will set an angle for your render. This is the camera. We'll come to the view. I'll change the resolution 1536 to 1920. This is the Instagram post resolution, and I'll change the focal length to 85. You can set your okay, this is good. And after you have done setting your camera, it is important to unlock this camera, otherwise when you move, your camera will also move, and that's not something that we want. So okay, this is good, and now we'll set the Redshift IPR. Just come to the Redshift tab and click the Redshift button. This will set a Redshift drop and a Redshift IPR. Come to the Redshift drop. Come to the Redshift drop, and in the output, what I'm going to do is I'll just keep this, so turn this on, and in the Redshift advanced, I'll just progressive passes to 120 because I'm just testing right now. Also come to the volume scatter and enable the volume scattering and decrease the scattering to 0.05. Now when we render this, we will see our geometry, but there will not be any color. So let's just render it. This is our test, and as I said, there's no color here, so there's no point in moving ahead. Now we will be creating the materials, and come to the material section here. We'll use I used a Redshift material builder. Let's name it Sim. Let's go inside, and what we are going to do is we will be using the color attribute that we already have on our geometry and our hair, and we'll use the same color with our standard material, with our Redshift material. So use a RS point attribute node here, particle attribute lookup and just connect the out color to the base color in our standard material, and this way the base color will be the same as that of the color that we generated in our simulation. In the standard material, we are going to make some changes. Reflection should be 1. I'm going to increase the roughness a bit. I'm going to use subsurface scattering here for this specific project. So we'll increase the weight here to 0.3. 0.3 seems nice, and we'll decrease the scale to a similar value of around 0.25. Let's do this. Also, we can play with the radius and color as well. I'll increase the blue value here. Okay, so this is enough. We'll come to the object area, click on the Sim Geo geometry network and come to the render here and select our material. Now we have applied our sim material to our sim geometry, and finally we can see how it looks. Okay, so this is not what I expected it to be. So we are going to make a couple of changes here. Come to the lights and let's first decrease the intensity. The intensity needs to be 0.5. We'll decrease it by half, and also turn on the normal intensity here. Do the same for the second one. Make the intensity 0.5 and turn on the normal intensity. And inside the sim, what we are going to do is we'll change the color. We'll make the pink a little saturated. This was a little too light for my taste. We'll make it a little saturated. I'll do the same here as well, so it pops. And another thing that we'll do is come in the sweep after the simulation, and we'll just make it a little bit fat. That's all we need to do. Increase radius a little. So now let's run the simulation again, and yeah, okay, this is looking good. Let's do the final render. So this was the video, guys. I hope you guys enjoyed it. You can come to the settings and change the color controls here, increase or decrease the contrast and exposure. Also make the curve, you can adjust the curve however you want. So this was the first video that I created, first Houdini tutorial that I created. More videos are coming. I'll be creating 50 more Vellum tutorials. I'll be creating 50 flip tutorials, and after that I'll be creating 50 particle tutorials as well. This is my goal by the end of September 2023. So just subscribe to the channel if you want, and you can check out the project files on my Patreon. The links are in my the links are in the description, and also the next video will be a basic clothes simulation. We are going to cover some of the basic simulations for the first few videos, and then we will move to advanced one. So thank you for your time, and let me know in the comment section how I did. This was my first video, so thank you. If you have any suggestions, please let me know. Bye.